Welcome to the Explainer. Today, we're doing something really exciting. We are taking a completely structured, step-by-step journey to absolutely demystify Agentic AI and map out exactly how you can master it. Look, whether you're a total newcomer to this space or you've been dabbling with basic AI assistants and you're ready to build systems that actually execute complex tasks autonomously, you are in the perfect place. We're going to break down the core concepts and give you the exact learning modules you need to go from a beginner to a true architect.
Here's our map for today. We'll cover the evolution of Agentic AI, automation versus Agentic AI, the anatomy of an agent, tokens and context windows, and finally, your step-by-step learning path. All right, let's jump straight into section 1, the evolution of Agentic AI. Think about how we got here. We started with narrow machine learning, which was honestly basically just making predictions, like forecasting sales based on past data. Then we moved to deep learning, using neural networks to tackle much more complex stuff like image recognition. And then, boom, the generative AI boom hit, right? Suddenly, models are writing poems and drafting travel itineraries out of thin air. But here is the massive, game-changing shift. Gen AI will write your itinerary, sure, but Agentic AI, it will actually go out and autonomously execute it. It'll book the flights, reserve the hotel, and even set up your out-of-office email for you. Which brings us to section 2, automation versus Agentic AI. A lot of people mix these two up, but there is a very clear divide here. Traditional automation, like robotic process automation, is, well, it's deterministic. It's rule-based. Think of it like a train stuck on fixed tracks. You set a rule, it follows it blindly, and then it stops. But Agentic AI, that is non-deterministic. It's way more like a GPS-guided car, actively navigating around sudden roadblocks. If a new customer signs up, an agent might research them, realize they're in finance, and dynamically pivot to write a totally customized welcome email tailored right to their industry. It adapts.
So essentially, Agentic AI uses its own internal reasoning to make decisions in real time. If a process breaks mid-task, say your cab gets canceled on the way to the airport, the agent uses its intelligence to pivot, check the live traffic, and find an alternative solution. And it does all of this literally without you ever having to step in. All right, let's look under the hood. Section 3, Anatomy of an Agent.
The very first piece of the puzzle is the brain. This is the foundational large language model doing the actual thinking, reasoning, and decision-making. For our learning path, we're going to focus heavily on the Claude family of models from Anthropic. Why? Because they're engineered with constitutional safety, which basically means they have built-in guardrails, and they possess the incredibly advanced reasoning needed to act as this central brain. Next up, we have tools. Look, a brain is great, but it needs hands to interact with the outside world, right? Tools are simply external APIs or apps. That could be a search engine API to browse the web, a basic calculator, or a direct connection to a GitHub repository. You just give the agent access to these tools and it decides when it needs to use them.
But how exactly does it make that decision? That brings us to the planning framework. And specifically, we're talking about the REACT loop, which stands for reason and act. The agent thinks about the task, takes an action using one of its tools, and then observes the result. Did the code compile? No? Okay. It reflects, adjusts its approach, and tries again. It just loops continuously until the goal is completely achieved.
And finally, memory. If you ask an AI, what's the weather like in New York, and then instantly follow up with, will I need an umbrella, it needs memory to know you're still talking about New York. Memory ensures your agent maintains the context of your multi-turn conversations. This is absolutely vital when you're building massive, complex applications over a long dev session.
Moving right along to section 4, tokens and context windows. So you really have to match the brain to your specific use case here. If you're debugging 10,000 lines of server logs for a distributed app, you bring in the heavy hitter, Opus. For daily coding, web apps, or GitHub pull reviews, Sonnet is your absolute sweet spot. But if you have 50,000 customer support tickets that just need rapid categorization, you go with Haiku for its blazing fast speed and lower cost. But here's the catch. No matter which model you choose, you're paying in tokens. Tokens are basically the raw currency of LLMs. A token isn't exactly a word, it's a unit of text roughly equal to 4 characters. Honestly, even just typing out please and thank you to your AI eats up tokens. So knowing how to manage them is an essential skill because it dictates your input limits, your output limits, and of course, your project costs. Now check this out, 1 million.
Claude, Opus, and Sonnet boast a staggering 1 million token context window. That's its working memory. To put that into perspective, you aren't just asking it to write a tiny snippet of code. You can drop entire massive code bases, huge log files, and sprawling documentation directly into the agent's brain, all at once. It is wild.
Okay, now for the roadmap. Section 5, your step-by-step learning path. Phase 1 of your journey is all about the foundations. You're going to start by setting up your Visual Studio Code environment to interface with Claude. Then you'll dive into multi-agent orchestration, which is basically learning how to get different agents to talk to each other to complete a bigger goal. But the real secret sauce here is prompt engineering. Guys, English is literally the next major programming language. You're going to learn specific frameworks like RTF, role, task, format, to command these agents perfectly. Once you've got that down, we step it up in Phase 2. Here, you'll establish strict coding standards using a specific file called claude.md. This file tells your agent exactly what your best practices are, so it doesn't just write a bunch of spaghetti code. Then, you'll learn to generate full UI and UX designs. And crucially, quality engineering. You're actually going to instruct the agent to automatically build its own unit and integration tests. It literally checks its own homework.
Finally, Phase 3 brings the whole shebang together. You'll teach your agent to auto-generate comprehensive technical docs that match your code perfectly. You'll integrate these agents into CI/CD pipelines so your software automatically tests and updates itself. And most importantly, you'll lock down your enterprise agents using least privilege security. You're ensuring your AI only gets access to the exact tools it needs and absolutely nothing more.
Conquering all of these modules leads you to one incredible goal: becoming a Claude certified architect. This isn't just some basic vocab test. It is a highly sought-after scenario-based certification. It proves you can actually think like an orchestrator to solve real-world complex development problems using agents.
The fact is, what used to take developers months of grueling manual coding can now be shrunk down to days, hours, or literally mere minutes. The tools are fully ready, the context windows are massive, and your path is mapped out directly in front of you. The autonomous era isn't just coming. It is already here. So the only question left for you is, which agent are you going to build first? Take that first step, get your environment set up, and I'll catch you on the next explainer.